Okay, this video is looking at another way of solving quadratics. So you might have discovered in the last one that if we encounter a quadratic equation where the solution isn't integers, so it isn't a whole number or an easy decimal number, maybe it's a square root of a number or a very long decimal, it's going to be very hard to work out what those factors of AC are that add up to your B term. In that case, we are going to solve it by completing the square. Now, we should already know how to complete the square, but in case we've forgotten, remember that in our form ax squared plus bx plus c, we need to find that b over 2 term and square it so that we end up with ax squared plus bx plus b over 2 squared. Then remember we subtract b over 2 squared to keep it equal, plus c. And then we would factorize this part as our perfect square. So we want to be able to complete the square of a quadratic expression, solve that quadratic then once it's factorized using our null factor law, and recognize when we have the form that's going to provide no real solutions. So it would technically give you an imaginary solution, but that's not really useful to us. So there's no real solutions, and we'll show you how to do that in a sec. First example asks us to solve x squared plus 4x plus 2 equals 0. Now, I don't know about you, but I can't think of any factors of 2 that are going to add to 4. So here is one where we're going to need to complete the square. So we need to work out what is our b over 2 squared term. So 4 over 2 just gives us 2. So it's going to be 2 squared. So let's write out, we've got x squared plus 4x plus 2 squared minus 2 squared plus 2 equals 0. Now we know this bit is now a perfect square. So that will factorize into x plus 2 squared. We still have minus 2 squared plus 2 equals 0. We keep simplifying that. So that's minus 4 plus 2. Let's just simplify minus 4 plus 2 into minus 2. We now have here the difference of 2 squares. This is good. If you don't have the difference of 2 squares, you have to stop here. So as long as this is a minus, then we can use dots. If it's a plus, we can't go anywhere. So we're now going to take the square root of both things. So we're going to have x plus 2 plus the square root of 2 and x plus 2 minus the square root of 2 equals 0. So our solutions, given our null factor law, is now that x plus 2 plus root 2 equals 0, or x plus 2 minus root 2 equals 0. So x plus 2 plus root 2 equals 0, or x plus 2 minus root 2 equals 0. So here we would have x equals negative 2 minus root 2. And here x is going to equal negative 2 plus root 2. So we can say that x equals negative 2 plus or minus the square root of 2. There we go. We've solved completing the square. Some people prefer, when up in this original equation, to write it out a slightly different way. They like to move that c term over to the other side, and then when you're adding and subtracting your b over 2 squared, you just add it to both sides. I personally am not a big fan of this, but I'll show you just in case, because it might work better for you. So they'd go x squared plus 4x equals negative 2, because they've moved that 2 over. They'd then go x squared plus 4x plus 2 squared equals negative 2 plus 2 squared. So you can see we've added it to both sides rather than adding and subtracting from the same side, because this is still going to keep it equal. We've added the same thing to both sides. You can then factorize this to x plus 2 squared equals negative 2 plus 4. So we're just going to leave that as positive 2. Now here you can see we're exactly at this point here. Yeah, just that we've taken the negative 2 and it's now a positive 2 because it's on the other side. So here you would just take the square root of both sides. So you'd have x plus 2 equals the square root of 2. This is going to be positive or negative. That's because if we're squaring this term to get back to 2, either positive square root of 2 squared will give us 2, and the negative square root of 2 will give us 2. So you have to remember to put that positive or negative in there. So then we have x equals positive or negative root 2 minus 2, which you can see is the exact same answer as down here, just in the opposite form. As I said, I don't really like that method as much. I find it a bit more confusing. I like keeping everything on one side. But if that one makes more sense to you, you are totally welcome to use it. I'm just going to stick with the other method, the first one we did for the other examples in this video though. So here we've got x squared minus 3x plus 1 equals 0 that we're solving. So our b over 2 squared becomes 3 over 2 squared. Remember, we don't need to worry about this negative here. So if we write that out, we get x squared minus 3x plus 3 over 2 squared. Remember, this one is always going to be a plus. Oops. Then we subtract our 3 over 2 squared plus 1, and that equals 0. This is our perfect square now. So that simplifies into x, just x minus 3 on 2 squared, because this is a minus, so this will have to be a minus. And then we've got, let's simplify this to 9 on 4. And we want to add 1, but ideally we want to be able to add it to this fraction here. So we're going to write it as 4 on 4 so that they have the same denominator. Simplifying that again, write that a little higher. We go x minus 3 on 2 squared minus 9 plus 4 on 4 gives us negative 5 on 4 equals 0. Now that's a minus, so we're good. We can do our difference of two squares. It becomes x minus 3 on 2 plus square root of 5 on 4. And then x minus 3 on 2 minus square root of 5 on 4. That still equals 0. Now remember, if we have the square root of a on b, that's the same as saying square root of a over square root of b. So this fraction here, square root of 5 on 4, we can rewrite that as the square root of 5 over 2. You can see that would give us a 2 as a common denominator there. So let's rewrite that. X minus 3 over 2 plus root 5 over 2. And then x minus 3 on 2 minus root 5 over 2. Scroll down a little to give us a bit more space. We can now simplify this. It becomes x minus 3 plus root 5 on 2. And x minus 3 minus root 5 over 2. So our null factor law there is going to be either the first bracket equals 0 or the second bracket equals 0. So x minus 3 plus root 5 on 2 equals 0, which would mean x equals 3 minus root 5 on 2, or x equals 3 plus root 5 on 2. So we can write that as x equals 3 plus or minus square root of 5 over 2. Okay, last example, because I realize this video is getting long. We've got x squared minus 5x plus 7. So we're going to have 5 on 2 squared. Let's go x squared minus 5x plus 5 on 2 squared minus 5 on 2 squared plus 7 equals 0. Our perfect square is going to become x minus 5 on, oh, that was a horrible 2. 2 squared minus 25 on 4 and 7, to put that over 4 becomes 28 on 4, 0. So x minus 5 on 2 squared, and that's going to become plus 3 on 4 equals 0. Now, this is a positive, so we cannot do dots. That means this is as far as we can go in factorizing. So actually we would write 3 dots, meaning therefore there are no real solutions. Okay, so if we end up with a plus at this stage when we're factorizing, that's it. You can't go any further. There's no solution to that quadratic. Same with any other kind of form. If you get to the point where you can't do dots with these, there's no solution to it unless it can be factorized in some other way. Have a quick go at these 3 to check how you're going with everything, and here are the solutions. So what I'd like to see in your books is attempts at these questions, the success criteria, and the notes from those examples, and then any questions about any of this work that you had. See you guys in class.